Everyone. The next topic in illumination model is component is specular reflection. So specular reflection is nothing but a white light reflection seen on smooth shiny objects. So this depends on the surface orientation as well as the viewer location. So I can say this white light reflection seen on smooth shiny objects. So this depends on surface orientation as well as the viewer location. Whereas, do you remember the diffuse reflection depends on the surface orientation but not on the viewer location. Example, consider I have a mirror here and RGB colors of these different colors falling on this will be reflected back. RGB. So if this is with respect to specular reflection, the object could be a mirror or metal surface, any shiny plastic, gold or silver. Whereas with respect to diffuse, light falling on this R, G and B, it's get diffused in all directions equally. R, this could be G and B here. So this is with respect to diffuse reflection. So as we are seeing, diffuse reflection could be any rough objects, grainy, clay, soil or any fabric. So if I want to model this, that is modeling specular reflection, then consider a scenario wherein which I have a surface here and there's a point source, light source here that is falling on this, and I draw a vector towards it, that is L. We have a normalized vector N and the reflection vector R, and we have a vector, unit vector towards viewer, that is V. So this angle we call it as phi. So R is a unit vector with respect to specular reflection direction, and V is a unit vector pointing to the viewer, and N is the unit normal surface vector, and L is the unit vector pointing towards light source. Fine. And this angle phi can be assigned the values 0 to 90 degree, so that it varies from 1 to 0 value, and we have a variable ns. The larger the value of this for shiny surface, and this ns value will be smaller value, that is less than 1 for dull surface. So consider this surface here, this is shiny and it has large ns value. So if that is the case, consider normalized vector and the light vector L that is pointing to the light source. If this is R, that is with respect to specular reflection, because of larger ns. So for shiny it is smaller ns value. In that case the reflection angle will be something like this. So it will be pointed very less. If it is a matte finish, if this is a normalized vector and this is a light source, vector pointing to light source, and this is the reflection vector, that case, for dull surface, the value of ns will be small. In that case it will be very broad. Example, consider this shiny metal surface. We can see a white light that is being emitted. So in the sense it will not be spread very wide. Could be this pen nib. So the range means this width will be very small, the amount of light that is reflected back. Whereas with respect to dull surface, the range will be more, so it gets spread. Fine. And we make use of cos phi function. So I can calculate specular reflection with respect to a point using w theta I small I cos ns phi, where this is a specular reflection coefficient and II is the intensity of light source and R could be N. R can be replaced with 2 into NL N minus L, and because cos phi is a dot product of R into V, and R could be replaced with this. Just for your understanding purpose, for the overall, assume I have a ball here. If the light source is here, if it is falling on this, so this looks very bright. If this is a metal, so on this particular object I can see a white light that is being emitted. So this we call it as specular reflection. So the amount of light that is reflected back by this surface, we call this as diffuse reflection. That is reflected in all direction. That is reflected in all direction. So this specular reflection is nothing but white light or the shiny reflection. So we can see this will be very bright, and we can see the portion of the metal ball, dark region of this. So this is nothing but we are able to see the object because of the ambient light. So this is ambient, that is the dark color, the object. So I can say if for the illumination model overall I need an ambient, diffuse as well as specular reflection model. So all these three models together we call it as Phong model. Thanks for watching the video.